In computational complexity theory, L is the complexity class containing decision problems that can be solved by a deterministic Turing machine using a logarithmic amount of memory. Space. Logarithmic space is sufficient to hold a constant number of pointers into the input and a logarithmic number of boolean flags, and many basic logspace algorithms use the memory in this way. Complete problems and logical characterization. Every non-trivial problem in L is complete under logspace reductions, so weaker reductions are required to identify meaningful notions of L completeness, the most common being first-order reductions. A 2004 result by Omar Reingold shows that USTCON, the problem of whether there exists a path between two vertices in a given undirected graph, is in L, showing that L equals SL, since USTCON is SL complete. One consequence of this is a simple logical characterization of L. It contains precisely those languages expressible in first-order logic with an added commutative transitive closure operator. This result has application to database query languages. Data complexity of a query is defined as the complexity of answering a fixed query considering the data size as the variable input. For this measure, queries against relational databases with complete information as expressed for instance in relational algebra are in L. Related complexity classes. L is a subclass of NA, which is the class of languages decidable in logarithmic space on a non-deterministic Turing machine. A problem in NA may be transformed into a problem of reachability in a directed graph representing states and state transitions of the non-deterministic machine, and the logarithmic space bound implies that this graph has a polynomial number of vertices and edges, from which it follows that Ni is contained in the complexity class P of problems solvable in deterministic polynomial time. Thus LNIP. The inclusion of L into P can also be proved more directly. A decider using O space cannot use more than 2O equals no time, because this is the total number of possible configurations. L further relates to the class NC in the following way: NC1 LNI NC2. In words, given a parallel computer C with a polynomial number O of processes for some constant k, any problem that can be solved on C in O time is in L, and any problem in L can be solved in O time on C. Important open problems include whether L equals P, and whether L equals Ni. The related class of function problems is FL. FL is often used to define logspace reductions. Additional properties. L is low for itself, because it can simulate logspace oracle queries in logspace, reusing the same space for each query. Other uses. The logspace class is therefore useful to model computation where the input is too big to fit in the RAM of a computer. Long DNA sequences and databases are good examples of problems where only a constant part of the input will be in RAM at a given time and where we have pointers to compute the next part of the input to inspect, thus using only logarithmic memory.